Alright, hello, welcome to my, it's gonna be a Hess's Law video. What we're gonna go on today is we're gonna practice solving a few questions. We're gonna do Hess's Law, question solving. So I've already sent you the worksheet for those of you who have kind of watched my videos and wanted to try to practice by themselves. Um, but but here's gonna be just another how I'll solve them. So like I said, I don't want to solve any of these questions in advance. Just because I think it'd be nice to work through them together, and then you could see, what errors I might make, and then how I correct them, and then you might make those similar errors, and you'll know how to correct it. So let's see what the question is. So I've opened up a worksheet right over here. We need to calculate delta H of the reaction, so I'm just going to write down what we need to get. Delta H of reaction. That's our unknown. That's what we want from the reaction. Let's do this front and center. Calcium plus 1 half O2 plus CO2. 1 half O2 plus CO2 reacts to form calcium carbonate, CaCO3. Well, I have a solid here, so I'm just going to put a gas here, and a solid just to remain consistent with if calcium says it's in solid state, we should state what state everything else is in. So here's the reactions that they're given. Calcium oxygen forms calcium carbonate, or calcium oxide. So we're given equation 1, calcium plus 1 half O2 forms calcium oxide. And we are given the second one, calcium carbonate, thermally decomposes. CaCO3 thermally decomposes to CaO and CO2. Okay, so these are the equations that were given, and our enthalpies that they give us, delta H is negative 635.1, negative 635.1 kilojoules per mole, and calcium carbonate is 178.3, 178.3 kilojoules per mole. So okay, I'll write these down, delta H1 and delta H2. Okay, so basically I'll change the color for now that we're solving it. Um, I like purple, so I'll change the color now that we're solving it. And we're going to see that, this is, it's kind of just like a mathematical equation. Our final equation has calcium carbonate on the right, so we should have calcium carbonate on the right. So my first step is to be reverse equation 2. I'll write that down, reverse equation 2. So what we end up getting is calcium oxide solid plus CO2 gas reacts to form CaCO3 solid and releases 178.3 kilojoules per mole of energy. Okay, so now we've got what we need on the right. On the left now we've got calcium oxide, which we definitely don't need on the left here. CO2, which we do need on the left here. And from equation 1, we get calcium on the left, oxygen on the left, and calcium oxide on the right. So this looks like it might already be done. We might have just had to flip one thing over. So let's add equation 1. So plus Ca solid plus 1 half O2 reacts to form CaO solid. And then let's start to cancel these out just a little bit. Let's just see. Calcium oxide here is on the left and is on the right here. So we can scratch them out. And then we've got calcium on the left, 1 half O2, CO2, and calcium carbonate on the right. So we're done now. So all we have to do is write our final equation, CaS plus 1/2 O2 gas plus CO2 gas reacts to form CaCO3 solid. And we can do the calculations. So we've just added these. So we do negative 178 plus, so because we just added the second equation, plus negative 635.1 kilojoules per mole. And our final value is going to be, oh, it's not on the screen. Give me a second to get my calculator. Here we go. So we've got negative 178.3 minus 635.1. So our delta H value, our final delta H of reaction, is equal to negative 813.4 kilojoules per mole. So okay, that's how we solved the first question. So we're already done the first question. So you can see it is very, very mathematical in how we solve for the delta H of reaction. So let's go back. I'm just going to scroll down here, and let's do question 2. Let's try a second one. So question 2. Okay. So here let's look at what we've got. 2NOCl forms nitrogen, oxygen, and chlorine. So here's the equation. 2NOCl decomposes to form nitrogen, oxygen, and chlorine gas. Oops, sorry. I'll assume this is the gas. It's a covalently bonded. So in this case, I'm just going to assume covalently bonded with nitrogen, oxygen, and chlorine. We'll just assume it's a gas at room temperature. Okay, and then our equations that we got is 1/2 N2 plus 1/2 O2 reacts to form NO. And finally, NO plus 1/2 Cl. NO plus 1/2 Cl2 reacts to form NOCl. And 90.3 kilojoules for the first one. Delta H equals 90.3 kilojoules per mole. And delta H2 is equal to negative 38.6. Negative 38.6 kilojoules per mole. And we want to find, again, what we're looking for, delta H of reaction. Okay, so here's equation 1, here's equation 2. And let's see how we're going to start on this one. So we want NOCl on the left. So we need to flip this equation around. So reverse 2. So instead we get NOCl reacts to form NO plus 1/2 Cl2, and the delta H2 is equal to 38.6 kilojoules per mole. And then here we see we've got 2 NOCl. So let's double reversed 2. So let's just double this equation. So instead we get 2 NOCl reacts to form 2NO plus Cl2. So that's the step that we're at now. And then let's see the third one. So this equation should probably be reversed too. N2 and O2 are on the right up here, so we need them on the right. So we got to flip this equation. So I'm going to say reverse 1. So reversed, we will get NO reacts to form 1/2 N2 plus 1/2 O2 with a delta H of negative 90.3 kilojoules per mole, delta H1. equals negative 90. And let's see how these relate to this. So here we've got 2NO, here we need 2NO, so we need to double the reverse of 1. So we just double this equation above. So we got 2NO reacts to form N2 plus O2. And doubling it, this is one thing I should have done up here already. Delta H2 is equal to, and this is delta H1. This is 2 times delta H2 and 2 times delta H1. So in this case, we've got negative 90.3 times 2. And this will give us negative 180.6 kilojoules per mole. And this equation, we're going to have 2 times 38.6. We're going to have 77.2 kilojoules per mole. 77.2 kilojoules per mole. And then finally, like the equations that we're dealing with now, right? We've doubled this, so we're not using this equation anymore because we've already done all the calculations involved with that. And we've reversed it and doubled it, and we've calculated the new enthalpy of that reaction. So instead, these are the only two left over that we really care about. And then we could do the final equation. So if we add these together, everything should cancel out now at this point. We've got 2NO on the left, 2NO on the right, so we lose NO. We see that there's no NO in our final answer, so we know that we need to get rid of that. But then we've got 1N2, 1N2, 1O2, 1O2, 1Cl2, 1Cl2, and 2. So we're done now. We just add them together. So our final equation will be, I'll just change this. Our final equation will be 2NoCl reacts to form N2 plus O2 plus Cl2. And if we add these two together, 77.2 minus 180.6, our delta H of reaction comes out to be negative 103.4, and make sure to always put your units, kilojoules per mole. I always like boxing in my final answer, because then an examiner could look at it and go, oh, okay, that's this is what I'm looking for. They've got the correct value. They've got the correct units. Therefore, they must have done their calculations correct. Otherwise, you wouldn't have come out with the right final answer. If you come out with the wrong answer, then of course the examiner can look through and give points where points are earned. But of course, if you end with the one final answer, it simplifies the examiner's job just a little bit. So okay, I'm going to see if there's maybe one more we can solve before the end. So let me go over. I saved another one right here. Delta H. Let's see, these ones look a little bit more complicated. There's 3 equations. I'm going to see if there's one with 4. Oh, that one's going to be a tough one to solve. So you're going to have to bear with me on this one. Because like I said, I haven't solved these in advance. Because I want to work through them with you guys. I want to kind of talk and show you my logic of working through them. So we need delta H of reaction. So question 3, we need delta H of reaction for the equation HCl gas plus NaNO2 solid reacts to form HNO2 liquid plus NaCl solid. NaCl solid. So this one gives us 4 equations. So of course, it's extremely important to stay organized with these. So I'm going to do this one a little bit more organized. Equation 1, equation 2, equation 3, and equation 4. So equation 1, we've got 2 NaCl plus H2O reacts to form 2HCl plus Na2O. And that's solid, liquid, gas, solid. Solid, solid, liquid, gas, solid. Okay, equation 2, what do we got? We got NO gas. I'll change the colors just for each equation. NO gas plus NO2 gas plus Na2O reacts to form 2NaNO2. 2NaNO2. And that's gas, gas, solid, solid. Gas, gas, solid, solid. So here, this is just what I just noticed. You can already see that these equations, right? We got NaNO2 right here. So we can see that this needs to be reversed because that needs to go on the left-hand side. And we can see that we've got Na2O, and this is Na2O. So if we flip this one over, we'll have to flip this one over because we want the Na2Os to cancel. We see in our final equation, we have no Na2O. So we know that these two reactions need to be reversed. So if Na2O is on the right here, it needs to be on the left here. But we need this to be on the left. We need the NaNO2 to be on the left. So we're going to have to flip this one too. So that's just what I just saw. I'm just trying to start to solve this while I'm working through the question. So okay, the next one, NO gas plus NO2 gas. Sorry, I thought I was writing down the same equation again. NO2 gas reacts to form N2O plus O2. So that's gas, 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 gas. N2O, good. Just making sure I wrote that down properly. N2O. It looks even less like a 2 now. And the last one, 2HNO2. 2HNO2. Liquid reacts to form N2O gas. N2O gas. O2 gas. And H2O liquid plus H2O liquid. So if you can pause the video here if you want and just try to solve this by yourself. I'm just going to erase this N2O, make that look a little bit nicer. And same thing with this NO2. Yes, there we go. So you can pause this video right now and try to solve this question, and then you can come back and you can see how I solved it if you get stuck. So give me a second, I got to write down these delta H values. So let's write that down in a nice light blue. Delta H1, delta H2, delta H3, and delta H4. So 1 is 507 kilojoules. 507 kilojoules per mole. Negative 427 kilojoules per mole. Next one is negative 43 kilojoules per mole. And the last one is 34 kilojoules per mole. Okay, so let's see how this is going to work. Okay, let's see what we want on the left and what we want on the right. So here we need HCl on the left, so we need to flip this equation around. We'll need to, I'll just say we'll need to reverse this. Just for now. This is just me, how I would solve the question and how I'd start. Then we need what else? NaNO2 on the left, and this is NaNO2 on the right. And there's no other NaNO2, so it only comes from this equation. So we're going to have to reverse equation number 2. Then we want, let's see, we want NaCl on the right, so that comes from flipping this over. And we want HNO3 on the right. So where is HNO3? Or HNO2. HNO2 is right down here in 4. So we're going to have to reverse this one too. And then we could see, what else. We'll probably need to use this equation 3 somewhere. But I don't know where it's going to get used now because it's only equation 1, 2, and 4 right now that have our desired products in it. But we'll probably have to use number 3 to cancel out something either on the left or on the right. So let's reverse them. Okay, so I'll just say reverse 1, reverse 2, and reverse 4. So then, right, this would be a very, very long answer question and would be worth a lot of points. So let's see what reversed 1 would look like. We'd have 2HCl plus Na2O reacts to form NaCl, 2NaCl plus H2O. And our new delta H1 is equal to 507, negative 507 kilojoules per mole. Okay, let's reverse number 2. So instead what we get is NaNO2, 2NaNO2 reacts to form NO plus NO2 plus Na2O. So I'm not writing the state symbols now because I'm still working on my fine drawing skills with this tablet. So our new delta H2 is equal to 427 kilojoules per mole. And we have to reverse 4, so that's the last one. N2O plus O2 plus H2O reacts to form 2HNO2. And our new delta H value is going to be negative 34 kilojoules per mole. So okay, so now we've successfully reversed these. So I'm going to erase the top 3 just because I need to make more space on this sheet. So I'm just going to erase these 3 that we've reversed. We've copied down the new delta H values. We haven't doubled anything or multiplied anything or added anything in this case. So we're just rearranging the equations to be what we need them to be. So, and number 4. Okay. So that's what we got so far. So let's see, let's just see what theoretically, if we just added all of these together, let's see what we would get, because then we could see where we'd need to use equation 3. So just, theoretically add them all together. Let's just put a line down here and pretend like we just plus them all together, and let's see what we get, and let's see what we can cancel out. So we get 2 HCl plus Na2O forms plus 2NaNO2 plus N2O plus O2 plus H2O reacts to form what's on the right, 2NaCl plus H2O plus NO plus NO2 plus Na2O, and then finally plus 2HNO2. Okay, so let's see what we can cancel out. Let's see what these equations have resulted in us being able to get rid of. So we've got H2O here on the left and H2O on the right. So H2O doesn't matter anymore. We've canceled it out. We've used it up. NO here, nothing on the right. Na2O, Na2O here, gone. And gone, good. 2NaNO2. Let's see. 2NaNO2. No, nothing there. But we want NaNO2 in our final answer, so we can't cancel that. We want HCl. but we don't want N2O. So N2O we're going to have to get from this equation somewhere, so we're going to need to get that somewhere from here. NaCl we want in our final answer, and HNO2 we want in our final answer. We just don't want this NO2, so we've got NO2 and N2O we see down here that we don't want. So we've done the right thing. We've added all three of these together. So let's see what the new delta H value is, and then let's write out the final. Let's write out the equation that we have. Then delta H. I'm going to do delta H added. Delta H add. So we've added negative 507. Negative 507 plus 427 minus 34. And our new delta H value, once we add all three of delta H1, delta H2, and delta H4 together, our new is negative 114, negative 114 kilojoules per mole. So that's our final equation down here. So I'm just going to erase these three off because we don't need them. We just got to keep track of this delta H value. So I'm going to erase all of this. So we've done the right thing so far. I'm pretty happy with how we've worked through this. Okay, so let's write a new equation 1 up here. A new equation 1 is going to be 2HCl plus 2NaNO2 plus N2O plus O2 reacts to form 2NaCl plus NO plus NO2 plus 2HNO2. And the delta H for this reaction is negative 114 kilojoules per mole. So let's see how we can add these together, right? We want to cancel off NO and NO2. It's on the left here and it's on the right here. So we've already got it. We don't need to reverse 3 anymore. So we just need to do plus equation 3. So plus NO plus NO2 reacts to form N2O plus O2. So let's see what this summary reaction is. And this reaction was negative 43 kilojoules per mole for this one. So we need to add the delta H. So this is delta H F. So we're almost at the final right now. So I'm doing delta H final. Let's see how we can cancel this out. NO2 on the left of the equation, NO on the right. So those cancel out. NO2 on the left, NO2 on the right. Those cancel out. O2 on the right, O2 on the left. Those two cancel out. And N2O on the left and N2O on the right. Those two cancel out. So our final equation is 2HCl plus 2NaNO2 react to form 2NaCl plus 2HNO2. And our delta HF, we just add these two together. It's negative 114 minus 43. Our delta HF in this case is negative 157 kilojoules per mole. But we see our equation here, our final equation here, our final is not equal to this one. This one is 1 to 1 to 1 to 1, and this is 2 to 2 to 2 to 2. So we've got double the HF value that we need. So instead, we just need to reduce. So in this case, we just reduce it. We drop the 2, drop the 2, drop the 2, drop the 2, and this needs to be divided by 2. So our final equation is HCl plus NaNO2 reacts to form NaCl plus HNO3 with a delta HF value of negative 78.5. Negative 78.5. So I'm just going to erase this to make the space. Kilojoules per mole. Box in your final answer. And we're done. So you see, right, the first step was just rearranging the equations to get what we want on what side, to get what our final products we want on each side. And then we just left out this one because we didn't really know what he was doing. We added them together, we figured out the net equation, then we figured out, okay, that's what number 3 needs to be there for. So hopefully this was helpful. I'll see you in the next video.